All right, guys, here goes the next thing we're going to talk about, triangle proportionality theorem. We're going to be dealing with lesson 18.3 today. And if you'll turn to page 266 in your book, you'll see this thing called the triangle proportionality theorem. I'll read it to you. If a line parallel to a side of a triangle intersects the other two sides, then it divides them proportionally. Well, let's look at what that means. So right next to the triangle proportionality theorem on the top of page 266, you'll see this diagram. And we are told right here that these two sides are parallel. Line RM is parallel to line PE. That's what these two arrows right here mean, parallel. So what we can say then is that this part divided by this part will equal this part divided by that part. So when you see triangles and one side is cut by a parallel side, then we get some ratios. So B over A is equal to C over D. Another way to look at it, you could say B over C equals A over D. So either one of those proportions will work. And we're going to solve some problems using that triangle proportionality. So here's the next one I want you to look at. This is found on page 267. Okay, Clarissa needs to find the distance across the lake. The known measurements are shown, so we need to help Clarissa find the length of segment DA. So let's see what we can figure out. Well, side ED is parallel to side BA, so that's going to give us triangle proportionality. So that means 27.5 over 54. So this part over that part will equal 29 over, let's call it X, for the length of the lake right there. And so at this point, we've got a proportion, so we just cross multiply. So 27.5 times X equals 54 times 29. All right, when you do the math, 54 times 29 is 1,566. And so 27.5 X equals 1,566. So we're going to divide both sides by 27.5. And then, pardon me, X is about 56.9, and I think our units are kilometers. Okay, so we had to do a little rounding there. I actually got 56.9454545, and so that's about 56.9 or about 57 kilometers. All right, this diagram comes from the bottom of page 277. We're asked to consider triangle SAT. Okay, I've considered it. Have you? I hope so. What do you notice about triangle SAT? Well, line MR cuts through it, and line MR is parallel to side ST. So we're going to have some triangle similarity going on. So take a moment and see if you can color code the sides or figure out which side relates to another. So I've marked segment AM in blue and segment MS in blue and segment AR in red and segment RT in red. So let's see. The measure of segment AM over the measure of segment MS will equal the measure of segment AR over the measure of segment RT. And that literally is what this one says right here. So definitely A is true. Now let's see if it goes the other way. AM over AS equaling AR over RT. Well, that's going to be false. And the reason that one is false is because here they're talking about this whole segment AS. So for this to be true, this one have had to have an AT in the bottom of it. So if it had been AT, it would be true, but as written, it's false. So now I'm going to get rid of all those strokes, and let's try number 10. We're using the same diagram for number 10. So the measure of segment AM is 8, and the measure of segment AR is 12, and the measure of segment RT is 5, and we want to know how long is MS. So I'm going to go 8 over X equals 12 over 5. One thing I really like about these problems is the ratios almost kind of set themselves up. Notice we have 8 over X and 12 over 5. And that's the ratio we wrote. 8 over X equals 12 over 5. Now we'll cross multiply, and we get 12X equals 8 times 5, which is 40. And when you divide both sides by 12, you get X equals 3.3 repeating. So that's about 3.3, or you could say that's 3 1/3. So any of those would be a pretty reasonable response for that. All right, on page 268, at the top of the page, you find a new math term, the parallel proportionality theorem. I won't read it to you, but you can pause this and read it. And basically, it says if we have a triangle with multiple lines parallel cutting through it, then we just get all kinds of proportional parts. So this problem actually is 6 problems in one. So on page 268, you have the opportunity to do 6 different problems. So we're going to kind of do these together. So let's look at what this bit right here is telling us. Well, that's telling us that each of these lines are parallel. And so that's what allows us to use this proportionality part. So we're going to do part A first, where we're looking for the length of segment ET. Well, we can say 48 over X equals 36 over 24. So 48 is to X as 36 is to 24. So after we cross multiply, we wind up with 36X equals 1,152, dividing both sides by 36, and X is 32. So as I work each one of these problems, I'm going to get rid of the work and add the information in. So that guy we now know is 32. Well, let's do B next. B asks us to find the length of segment AI, so we'll call that one X. And we have some choices. I'm going to continue to use 36 over 48, and that will equal X over 40. Notice that 36 and X are from the top part of the diagram, and 48 and 40 are the corresponding parts on the bottom part of the diagram. So then we're going to cross multiply and solve that one. So hit the pause button and give that a shot. And after you cross multiply and divide, hopefully you got X equals 30 there. So now I'm going to add that to the diagram. And if we're looking at Part C wants us to find segment AT. Well, that's this one. So we have to be a little careful when we do this. Segment AT is going to correspond to segment RE because those are part of the parallel lines. So x over 27. And then up here in this triangle, in this diagram, the length from A to C is 36 plus 24. So that goes with our x because that's part of this bigger triangle here. So let's see, 36 plus 24, that's what, 60. And then the part that goes under the 60 would be the 36 coming from that triangle there. So cross multiply and divide. So after we cross multiply and divide, we get that the length of segment AT is 45. All right, so there's a little bit of how that triangle proportionality works. So on page 271 and 272, if you'll be responsible for problem number 1, 2, 6, 7, and 8 through 15, along with the problems from the last video, and then we'll talk about those, answer any questions next time we see you. That'd be, and then if you have any questions, feel free to come see me for tutorials. All right, thanks a bunch.